VIVEKA Learning Extra. Welcome to VIVEKA Learning Extra. We provide Kolkata's best teachers for any subjects and extra curriculum in online or offline. For more details, kindly contact us.
Hi friends, this is Anirban. Today we are going to discuss an important topic of mathematics. This is called variation. This topic has a wide range of application in physics, chemistry, and also in different other branches of mathematics. So, what variation means? Variation means that if we have two variables, then one variable will vary with respect to other. This is called variation. Suppose we have two variables x and y. If anyone varies with respect to another variable, then we call that the two variables x and y are in variation. Then we call x and y are in variation. This is a formal definition of variations. Okay. Now, there are mainly two types of variation. Variation are mainly of two types. First one is called direct variation. Second one is called inverse variation. Now, we shall discuss both these variations in detail. First, let us come to direct variation. Let me use a short form, direct variation as dv. So, what direct variation is? What is the concept behind it? Suppose we have two variables x and y again. If with increase in x, suppose we have two variables, x and y are two variables. Now, as x increases, if y also increases, and moreover the ratio of x and y at each instant is constant, then we say that x and y are in direct variation. So what we have? If for direct variation, we have x increase if y increase, and x by y will be constant. Then we call that the variation will be direct variation. For example, suppose we can take the example of a railway station. If we visit a railway station, the car parking area, you might have noticed that the agencies, they charge the rates as per the time you keep your vehicle. So let us assume that if you keep your vehicle for 1 hour, suppose let us assume that they charge 30 rupees when you keep your vehicle for 1 hour. They charge 60 rupees when you keep your vehicle for 2 hours. They charge 90 rupees when you keep your vehicle for 3 hours, and 120 rupees when for 4 hours. Now, let us say these values as x. Which values? The amount, that is 30, 60, 90, 120, we are taking them as x. And let us take the time to be y, that is hour, to be y. Now you can see with the increase in y, as y increases, when y is 1, x is 30, when y is 2, x is 60. So as y increase, you find that x is also increasing. Moreover, if you observe one thing, you will find that x by y at every instant, that is x by y, when you take the first two values, that is 30 by 1. Again you take the second value, x by y, 60 and 2, that is 60 by 2. This is also 30 by 1. Again for the third instance, x by y becomes 90 by 3. This is also equivalent to 30 by 1. And also 120 by 4 is also 30 by 1. So you find that x by y is always a constant. See, 30 by 1, 60 by 2, 90 by 3, 120 by 4, it always yields 30. Hence we can say that x by y is always constant. So we can come to a conclusion, we can conclude that x and y are in direct variation. This is the concept of direct variation. This is a very simple concept. The variation chapter itself is very simple, but I would like to say that this is a very important chapter as it has wide range of applications in mathematics. Not only in mathematics, but it also has a wide range of application in physics and chemistry also. We will discuss some examples. Okay, so first you got the concept of direct variation. So how to write direct variation? We write direct variation in this way: x directly proportional to y. This is how we write direct variation. Now to remove, this is called proportionality sign. To remove, when we remove the proportionality sign, we write x equals to k by y, where k is the constant. Which constant I am talking about? See, in the last example we found x by y is 30. So for the last example we found x by y to be 30. So this k for the last problem becomes 30. So this is the concept of direct variation. Now a real life example of direct variation can be seen in physics. We have a very good example. It's a relation between volume and temperature of a gas. Let us assume volume of a gas to be V, and temperature of gas to be T. Now if all the other things are kept constant, like other things, for example pressure and remaining other pressure and supply of heat, etc., if these are kept constant, we see that when we raise the temperature, when the temperature of the gas increases, the volume also increases. With the increase in temperature of the gas, the volume of the gas also increases. But this is only in the case when we keep the other things constant. Other things, for example, we can say pressure, when we have kept assuming that pressure is constant. Then with the rise in temperature of the gas, volume also increases. So we can say that V and T are in direct proportion. So V directly proportional to T. And we have just said that with the removal of proportionality sign, we get a constant V equal to KT, where K is a constant. K is constant. This is a simple example of direct variation. Now let us come to inverse variation. We said that we have one more type of variation, that is called inverse variation. Now let us see what that is. Okay, now we are coming to inverse variation. Okay, inverse variation, this is nothing but the reverse of direct variation. See, in direct variation we had, with the increase of one variable x, the other variable y was also increasing. But in inverse variation, if we have a variable x, if this increases, then y, this decreases. Moreover, and there is another thing that we need to remember for inverse variation, that is the product x and y of two variables is constant. In case of direct variation, we got x by y, the values of x by y at any instant was constant. But in case of inverse variation, the product x and y is constant. A very good example of inverse variation is seen in chemistry, that is Boyle's law. Boyle's law states that if temperature is kept constant, if we keep the temperature of a gas constant, then with the increase in pressure of the gas, let P be the pressure of the gas, then volume of the gas decreases, where V is the volume of the gas. Provided, we must never forget this, provided temperature is constant. This is an example of inverse variation. How we write inverse variation? So we got P and V are inversely proportional. That is, with the increase in P, V decreases. So we write, I just said that their product will be constant, PV equal to constant. Let us say it as K. So we get, from this we can write P equal to K by V. Now, in the previous case, in case of when we were discussing direct variation, I said that to remove the proportionality sign, when we remove the proportionality sign, we introduce a constant. And the reverse is also true. When we remove the constant, we get the proportionality sign. So from this we can write P inversely proportional to V. Thus we get P inversely proportional to V. This is how we write P inversely proportional to V. That is, if X and Y are inversely proportional, then X inversely proportional to Y. This is the notation. And to remove the proportionality sign, from this we can write X equal to K by Y, where K is the constant. So this was a simple case of you can say explanation of variation. Okay, now let us come to a problem. Let us discuss a problem. We have learned about the theory, we have learned the concepts. Now we'll discuss a problem. Okay, now let us assume that we are given a set of values. Let us assume that we are given a set of values. What kind of values we are given? Say we have two variables A and B. The values of A given are, the value of A is 25 when B is 10. The value of A is 30 when B is 12. The value of A is 45 when B is 18. And the value of A is 250 when B is 1000. I'm sorry, this is 100. This is not 1000, this is 100. So the value of A is 25 when B is 10, the value of A is 30 when B is 12, the value of A is 45 when B is 18, and value of A is 250 when B is 100. Now we need to check whether this is in direct variation or this is in inverse variation. So how we check? We just say, first of all, you observe that with the increase in A, the value of B is increasing. So with the increase in A, the value of B is increasing. Now we need to see whether the A by B ratio at any instant comes a constant value or not. Okay. So we take the first value of A, 25, second value of B, 10. This gives 5, 5, 5, 2. We get 5 by 2. Now let us see. Now we need to see whether the 30 by 12 also gives 5 by 2 or not. That is, second value we have 30 by 12. Now if we how can we divide it? We can divide it by 6, 5 divided by 2, 5. That is 5 by 2. See, we get 5 by 2, we get 5 by 2. Again, for 45 by 18, A by B, when A by B is 45 by 18, then in this case also we will get 5 by 2. We will divide by 9. When we divide by 9, 9 5 45 and 9 2 18, that is 5 by 2. Same for 250 by 100. When 250 by 100, when we have 250 by 100, this 0 0 will get cancelled, and 25 by 10 we already had 5 by 2, so 5 by 2. Thus we find, from this problem we find that with the increase of A, B is also increasing. Moreover, the value of A by B, the given values of A by B is always a constant. Hence in this problem we can conclude that A and B are directly proportional. So how we can write? We got the constant to be 5 by 2. We got the constant to be 5 by 2. So how we can write it? We can write it as A equal to 5 by 2 into B. Or to remove the proportionality sign, we can write A proportional to B, directly proportional. So this was a simple problem on direct variation. Okay, now we'll have another problem to check whether the variation will be inverse or not. Okay, Let us say we have two variables x and y. The value of x is 18 when y is 3. The value of x is 8 when y is 27/4. The value of x is 12 when we have y as 9/2. And the value of x is 6 when we have y to be 9. Now we need to see what kind of variation this follows. Well, beforehand I would like to tell that this is an inverse variation problem. How? Well, observe the first thing. Firstly, you need to observe. What do you need to observe? That with decreasing in the value of x, we find the values of y are increasing. Moreover, now you check whether the product x and y for all the values is coming constant value or not. Okay, first we see when x is 18, y is 3. When x is 18, y is 3. The product of x and y is 54. Next, when x is 8 and y is 27/4. This 4 and 8 gets cancelled too, and this gives 54. So we get 54 again. So for the two cases we have found x and y to be constant. Now for the third case, when x is 12 and y is 9/2. Cancel this out, 2, 6, and we get 54 again. And for the last one, 6 and 9, well, 6 into 9 is 54, we all know. So for this example, we find that x and y equal to 54 always. Thus, we get that xy is constant. So when xy is constant, we can write x inversely proportional to y. This is how we write 1 by y. Okay, before concluding this lesson, I would like to clarify one thing. The thing is that we may sometimes find that that x is increasing, y is also increasing. We may also sometimes find that x is decreasing, y is increasing. Such things we find most of the time. However, this is if x by y is not a constant. Even though x is increasing, y is increasing, or x decreasing, y decreasing, but x by y is not constant, then this cannot be direct variation. This is not a direct variation. For direct variation, x should increase, y should increase, or x should decrease, y should decrease, plus x by y should be a constant. If this is not a constant, then this is not a direct variation. Same goes for inverse variation also. Suppose that x is increasing, y is decreasing, or x is decreasing, y is increasing. If we do not get xy to be constant, if xy is not a constant, then x and y will not be in inverse variation. Okay, so this was a short discussion on variation chapter. Hope you guys like it. Thank you.